You should also have Jupyter. That's the code editor that we're actually going to be using for this, and you'll see why it's really good. If you weren't there for the Teapot intro that we did last Tuesday, or 2 Tuesdays ago.
If we have an Anaconda, would we already have?
I believe you would have Jupyter already. You should run these just in case. So just briefly explaining what each of these 4 things is doing. Jupyter gives us a notebook interface we're going to be using to write the code for today. Pandas is a data frame library. You can think of a data frame as a code version of an Excel spreadsheet, except without the limitations of Excel. Matplotlib allows us to make pretty graphs, or at least some kind of graphs. And SQLAlchemy allows us to design a database using code. By the end of this, we'll have taken our data set, cleaned it up, and then loaded it into a database that we can use for next week.
So SQLAlchemy already comes with Anaconda?
I don't believe SQLAlchemy comes with Anaconda. There's always a good way to check, though, if you have it installed. As long as you are in your environment, which if you have Anaconda, that's this little prefix here, your base or whatever else you've named it. You can always just try to import it, and if it works, it's installed.
Last week when we were doing the import, so the import just package them together, or
By default, any libraries that are not part of the core Python are not available for your code to use until you import them. So even things in the standard library, if I don't need to be running things with JSON, if I'm not using JSON files, I don't need to import the JSON library. In this case, these 4 libraries here they don't come with Python, so we need to install them. And then just like any other library that isn't automatically available, we need to import them as well. Yep. Okay. All right, everyone, let's get started. If you don't have everything, ask a neighbor to help you. We are going to need these 4 packages installed: Pandas, Matplotlib, SQLAlchemy, and Jupyter. And for our data sets, there is a link to this web page where you can download the CSV. If you don't have that, go ahead and download it because we're going to need it. So on the meetup page, just scroll down right there. Okay. So for today, we're going to take a data set, we're going to examine it, clean it up, and then use SQLAlchemy to design a database around it and load that data into a database. So the first thing we need to do is to actually open up the data and see what we are working with. So I'm in Anaconda, so I need to activate my workshop environment. There we go. So, yeah, this is Anaconda. If you haven't created an environment, don't worry about it. As long as you're in base or you're not using your system Python, you'll be fine. And I'm just going to cd into the codex thing. So the first of the 4 libraries that we're going to use, and we're only going to call it to open up our text editor, is called Jupyter. Jupyter gives us a notebook syntax that is great for data visualization and analysis. If you were at the very first of these 4 talks, you would have seen us use it looking at the Teapot intro. Now to run it, whatever directory you're currently in, all you need to do is run Jupyter Notebook from the terminal. That will spin up a server and open up your browser. So you can see I already have an IPython notebook in here, and this is my CSV that I downloaded. So for simplicity's sake, if you download the dataset to your downloads or to your desktop, you might just want to go to one of those 2 folders for the time being. Yep. So it's Jupyter Notebook. Yeah.
The command was Jupyter Notebook.
Yep. And it's PY.
I have the CSV, but I don't have the other folder on top.
So do you know where it was downloaded?
Yeah.
Do you know how to go to that directory where it's downloaded? So you're just missing Jupyter?
I have an icon there installed, right?
Mm-hmm. Okay, so all you'd need to do is open up a terminal and type in pip install pandas, or pip install, and then the 4 libraries that we're using here today, which includes Jupyter.
How do you change the like where it's looking?
Okay.
No, that little folder is not letting me.
Yeah, so on any Unix-based system, in your terminal you would use cd and then find the directory. So if you're on a Mac or a Linux machine, you would do tilde. If you download it to downloads, it would be in downloads. If you're on Windows, then if you go in PowerShell, it should also be CD.
It should open your browser. It should look like this. It'll open your browser up. It's spinning, it looks like.
Yeah, so you're good to go. We'll open up a file in just a second. Morning.
Yeah.
Oh, thank you. All right. For the 2 that just got here, we need to install the 4 libraries up there. If you have pip directly accessible, then just run that line up there, and also download the data set that's listed in the meetup page. It'll be a comment in the meetup page. All you need to do is go to that link, which takes you here, click export, and then CSV. So do most people have a screen up that looks like this right now, where you can access the OPD crimes data set? I'll take that as a yes for now. So to get started, once you have something that looks like this, you can access your CSV from this interface, preferably. You can click on New, create a new Python 3 notebook, and that should give us a brand new notebook here. At the top of our notebook, the first thing we need to do is import pandas. And then for simplicity's sake, we can do as PD, which renames imports for us. And then to run it, all you need to do is click Shift Enter. And the cool thing about this interface is it's just like running a REPL in Python. Just like typing Python in, and now you have the interactive prompt. You can it will run any of these code cells for you in whatever order you want them to run. So if we wanted to do something here, we ran this. We could go back and run this again. You can also change the cell type to Markdown, and Markdown would then allow you to document your code as you're going along. So now we have a heading that's embedded amongst the rest of our code. This is great for documentation. If you were doing a kind of data analysis, you could say, here's what I'm about to do, here's the code block, here's the output from that code block, and then I have another markdown block saying, here's what just happened. Now here's what I'm thinking, so let's do this now. It's really great. And the other nice thing is when you're done with your file, you can download as an HTML page, just put directly online, or PDF, or you can just take out the Python files. It's really great. So, actually going to open up my notes on this. Yep. So with pandas now installed, the first thing we need to do is actually import our data that we downloaded. So we do opd equals read CSV, and then give it the string of the file name. So in my case, I have it as opdcrimes.csv. You should make that text whatever this says here for your CSV file. It's probably uppercase. The only gotcha is if it downloaded with a space in the name, you might need to put a backslash like that, especially if you're on Windows. But once we have that in, just click Shift Enter again to run the cell, and we now have data imported into our Jupyter Notebook. Yeah. So that should say whatever the CSV is here.
And you can copy and paste it from that screen.
Yep. So as I alluded to before, one of the great things about this Jupyter Notebook interface is it handles a lot of really great stuff for us. So if we were to do opd.head, which shows us the first couple of rows in our data set, it gives us this lovely formatted table that we can look at. So we can see the first row of our data. We have our case number here, our timestamp, location, and because this is crime data, it's sensitive information. It's not going to give us the exact location. And even though it gives us some coordinates, it's only accurate to within a block or so. But you can see that we have case offense types, offense charges, charge types, disposition status, location types, all of that. And we can also do opd.info to give a more text-based overview of our data.
I got an error.
Mm-hmm.
Error manual pandas has no attribute read.
So it should be read_CSV. Mm-hmm.
And then that should be the same as, you know what, it is capitalized.
Yeah, so it's whatever your CSV is named. Okay. So in our info here, we can see that we have 181,260 rows of data, but our location actually has less null data, so that has less non-null data. So we might actually want to run a command that drops that information for us. But first, let's take a look at, let's actually clean up these column names. So we see that case is repeated a whole lot here. And we also see that case date time is, we can just call that timestamp. As well as if we strip case off the front of these, now we're going to have two locations. So one of the things that we can do is we can rename these columns. Or actually, also, if you from our session last week, dir is your friend, because if you don't know what is available to you when you are looking at an object, you can run dir and it will tell you everything. So if we run dir on OPD, these are all of the various things that we have access to. These dunder things at the front we technically shouldn't call. That's how private works in Python. But we have, we can start looking at, well, give me the absolute value of some columns. We definitely will be looking at things like drop NA, drop duplicates, a handful of other things. And what's also not listed in here is we can, in most cases, access the columns directly as though it were a native element. And what I mean by that is if we want to look at the opd.locations, or location, we can do .location there. And this references the actual column of data inside of our data frame, which, remember, is a grid like Excel. If we can't do this, which if we tried to access, opd.case location, that's going to give a syntax error because it doesn't like spaces. It doesn't know how to deal with that. So we would need to wrap it in this syntax that we saw before, as though we were accessing a dictionary. That will yield the same thing, but that's really messy. So what we can do with that is we can go ahead and rename some of these columns and then clean other ones up as well. So just to look again at our column names, we can do opd.columns. This is all of the column data, or the column names that we have. So the first thing is we can do opd.rename. That takes a column dictionary of the values that we want to replace. So we can give it case date time, and we can tell it that we want to replace that column name with timestamp. Or this case location. Well, that's an address, more or less. So we can just call it address. And then lastly, the regular location. If we look back up here, that is just a coordinate string. So we can just rename that coordinate. And
Are you missing one comma?
oh, yep, you're absolutely right. Yes.
This is not positional, it's kind of like you're treating it like a dictionary, right?
Yeah, well, we're actually passing this a dictionary. Now, by default, most if not all, of the operations that you run on a pandas data frame are non-destructional, or non-destructive. So if we wanted to do this in place, we could just overwrite the output. If we wanted to give this a different name, we can do that as well. But we also have this option to run things in place. And if we do that, and then run OPD columns again, we can see that we've changed the column name of timestamp, address, and coordinate. Now for the rest of them, we want to keep the names mostly intact, but what we can do is we can run generic operators on them. So we can do OPD equals OPD dot columns, and then we access the entire list there as a string, and then we can call lower on it. Now, string.lower just takes whatever string you're looking at, makes it all lowercase. Makes sense. So if we were taking case number, now we would have lowercase case space number. We can then string along another replace, and we can replace all of these spaces in there with underscores. Or there we go. We can replace them all with underscores. And then one more, we can run one more replace where, remember, at this last replace, everything has been lowercase and all the spaces have been replaced with underscores. So we can run a replace on underscore or case underscore. So that should give us, instead of case offense location type like this, we should just get all lowercase offense underscore location underscore type. So we run that. Oh, I didn't give it a. Yep, you're absolutely right. And we just give it an empty string.
And you can string as many as you want onto that for the replaces.
Yeah, so you can give anything you want to replace. It will just do. It's just like a find and replace in a text document.
Like you can add however many replaces you want.
Oh yeah, you can string these together as much as you want.
And the string is changing with each.
Mm-hmm. Yeah, so it's Pandas does a lot of the heavy work for you. We don't need to iterate through every single column name. When we call .string.lower, it is automatically applying that to every single element in that collection. Pandas does a lot of stuff for us, which is really great. So if we call opd.columns,
Yeah, I'm having the same problem.
whoops, let me double check my notes. If you can't tell, I'm a little rusty on my pandas. Hey, that's good. There we, okay. So, silly me, opd.columns, because we're overwriting the columns, not the actual thing. So if we just get rid of .columns there, well, this is all the stuff, but we just overwrote our database. Here's a great thing, though. If we run into a mistake, remember how I said you can run any cell in the order that you want? We can just reload our database for the time being. And you'll see that the number associated with that cell, this is the run order. So we can see that this is 15. We ran this after we ran this cell, which is number 3. And we haven't really changed the data yet. So all we need to do is rerun this cell, which should yield us these same columns, and then we can run this one again with opd.columns.
So the first one,
Line number 8,
after import,
the str replace.
Yeah, so yeah, that's everything we're doing.
rename columns was the second one you reran.
Yes.
So line 16.
Mm-hmm.
Well, input 16.
Okay, let's go back up a little bit. Yep.
Yeah, if you didn't.
What's the beginning of line 18?
It's just opd.columns because we are overriding the columns.
Thank you.
So now that we have these clean column names, unlike before, where if we tried to do this case offense location type, if we tried to access that directly, we would have to use the dictionary call syntax with all of that. We can now do this instead because its offense location type is just offense underscore location type, which means we can do our dot syntax, which is great. It looks much nicer, it's cleaner. And we're going to keep these column names like this because it's going to be easier for us to access that information once it gets into our database this way. So now, okay. So now what we can do is let's do print len and do opd. So this is the number of rows we currently have in our database or in our data set. It's always a good idea before you start working with your data to remove any duplicates that may exist. So we would do that by opd.drop duplicates, and we'll just do that in place as well. And print out the length afterwards. So this is a relatively clean data set in that there were no duplicates in it. The other thing that we might want to do is, let's say we were only looking at, we only cared about entries that had a coordinate associated with it. Now back up earlier in our file here, we saw in opd.info that a non-insignificant number of our rows had a null coordinate in it. So if we want to just drop, what we can do to fix that is we can do drop NA and do in place equals true again. Then we can print the length. If we run that, it has removed any rows that have NA as, or that have missing any values in them. So, yep. Yeah. So in place equals true just allows us to, it runs this, it makes changes to the database or to the data set in place, as opposed to if we would need to overwrite it, because pandas operations are non-destructive on the original, so it makes a copy every single time. If we have in place, then we don't need to keep overwriting our data set on every call. Yeah, so that's all that is doing. Okay, so now that we have a there are no null values in our data set, we can start looking at some of the information in there. For example, let's say we wanted to see all possible values, all unique values of a categorical column. One of the categories that we have is offense location type. So we can copy that here, or actually, we can just run this right here. So offense location type, if we want to get the unique values out of it, because now we're accessing a series, we can just call unique, and these are all of the unique values in this column. There's another column up here called status, and not really sure what status is, so let's look at it. I do see that it has mapped for at least the 3 values that it first printed out. So we can do opd.status.unique, and we see there's only 1 value in this column. If you only have 1 value in a column, it's not that helpful. So we can just remove that column from this data set. We can do opd.drop. Now it says columns, but we can give it a string of just status and it will work. And again, we can do our in place equals true to run that in place. And if we call opd.columns again, we can see that status is not in that anymore. I'll leave this up for a second.
New language.
Yep.
So the main reason we took status out is because there was just one number of data.
Exactly. If you have a column with only 1 value in it, it's not all that useful if you're trying to when you're doing data cleaning, because you can just say, well, the status is mapped. I don't care which row I'm calling. It was all just the same value. If it's not a value that is absolutely necessary for you to have in there, you can just remove it.
I know that it's just 1 value because it's just 1 array, right?
Exactly. When we called status.unique, it only gave us 1 entry. So just to check in on our data again, if we call the head, we can see that our column names have all changed, and we don't have status as a column anymore. So another thing we might want to do is to separate out these coordinates. If we wanted to query a database or a data set saying, I want to find things near this coordinate, it's a little hard to do that when the coordinates are all saved as a string, and we can't really, it's harder to query a string, especially when you're trying to do some kind of location-based analysis. So just we can look at our coordinate column. So they all look like this, and this D-type object, these are all strings in here, but pandas attempts to look at the column data and see if all of the values match a certain data type. If they don't, which in this case an object just means I wasn't able to determine exactly what data type everything was in this column. If you had IDs in there, then the primary keys in a database, it might give you D type equals int64, which is just a 60, in C language just means an integer represented with 64 bits, ones and zeros. But it'd be really nice, instead of having a dot coordinate column, if we had a dot latitude and dot longitude column of float values. That'd be really nice. We could actually do filters based on if it was above a certain latitude in Orlando. So in order to separate out this column, we're going to need to iterate over every value in here. we're going to need to remove the parentheses at the beginning and end of the string. We're going to need to split the value by this comma space. And then the resulting values of that and that we will need to cast to a float. So in order to do that, we're going to create some empty lists where we can store that data as we process it. So once we are done processing an individual element, we are going to put when I say float, a float is any number with a decimal point in it. And an integer that mentioned before, that N64, is anything that doesn't have a decimal point in it, any whole number. Because coordinates have this decimal point in there, we're casting everything to a float. If we cast this to an int, it would round up to 29, which isn't very useful. So we have our lat and lon storage. We're going to iterate through everything. So we can do for coord in our coordinate column. So we're now in a loop. The first, in this case, because it's iterating through every row, coord is this exact value right here. And we can do print coord and then type coord just to show that. And just so we don't iterate through everything, I'm going to run break, or I'm going to put break in here. When it hits break, that just escapes the loop. So we're only going to print out the first element of this loop here. So it is in fact a class, it's a type of string, and this is the exact value that we're working with. So the first thing I said we need to do is we need to remove the parentheses from around the string. Oh, we can do that by doing coordinate equals coordinate dot strip. Now, if you don't give strip anything, it's just going to remove white space from the end of the string. So space, new lines, tabs, whatever. It's great when you are iterating through a file, just the raw lines of a file, and you need to remove any white space, like the new line character from the end of your string. But in this case, if we give it something, we can give it this, and this is going to remove any instances of the opening or closing parenthesis from the beginning and end of the string that we give it.
So we might have to do it in a separate.
Yeah, we don't have to do that separately. Now, if we only wanted to remove that from the beginning or the end of our string, as opposed to both sides at the same time, there is such a thing as rstrip and lstrip, which will remove items only from the right or the left or the right side of the string. But we want to remove it from both, so that's all we need to do there. And we can print our coordinate again, just to make sure. And we see that the parentheses have been removed from both sides. The next thing we need to do is split this. So we can now call lat and lon equals coord.split with the comma space. Now, if you remember from last time, this is called variable unpacking. It's a really nice feature in Python. And this just says that as long as coord.split results in two elements, we're going to assign the first element to lat and the second element to lon. There's one more thing we need to do before we append anything to our list there. Yeah. So we can print out lat and, oops, a little much there.
Is it plural, lats and lons?
So the lats and lons are just the lists that we have up here. We're about to put information in there.
Okay.
Yeah. So we run this again. We see that we have successfully split out our latitude element and our longitude element. Lastly, we can do lats.append we cast to a float, and now we are adding the float, or the decimal number version of this latitude string to our list of latitudes. And we can do the same thing for our longitude. So that would be lons.append, the float version of lon. And just to show that that is in fact working, I'm going to break out of that, and we can do print lats and print lons. Now remember, with this break here, we're still only running on the first thing, and this code block here is safe to run over and over again because we keep setting lats and lons as empty values at the start of this block. So if we run this, we can now see that we started with a class string together, we removed the parentheses, we split it off, and appended the float versions to our list. Now, if this was still a string, we would see quotation marks around these elements. And in fact, just for the sake of example, if we don't cast to a float, we can see that there are now quotation marks around it.
I have a question.
Yeah.
What's your shortcut for copying the line above?
Oh yeah, so at least in this editor and some other editors as well, if you just need to copy the entire line without any text selected, you can do Command or Control C, just like you would copy a selection of text. If you don't have any text selected, it copies the whole line. So you might want to be on a separate line because then you get something like this in there, but that is copying the entire line as is. I actually prefer to go to the end of the line, do Shift up, and then I can just paste those all day, depending on the text editor. But that's...
You said lats and lons is being set to empty, but that only happens once, right, in the beginning?
Yeah, but it happens every single time we run this code block. So if I had lats and lons, oh, actually, this is a great teaching moment. So I can insert a cell above. If I put these in here, and so I now have removed setting lats and lons as empty lists before running this code block. If we were to run this, even though we are breaking after only one thing, you'll notice that after a couple of runs of this, we're not emptying out our list, and it is continuing to append that first item multiple times. So one of the powerful things with the notebook is the ability to go back, make changes, and make changes to things without having to reload the data every single time, like when you're writing a file. But it can also lead to some weirdness if you're not careful about it, like not clearing out your data set.
How come there's only a go forward symbol and not undo icon beside the fast forward there?
Yeah, there's not a...
You need to undo.
Yeah, you can't really undo a Python command. So I'm going to grab this back in there and delete that extra cell. And now that we're fairly certain that this is going to work, I'm actually going to remove the break and the print statements, because otherwise we're going to get a whole lot of text underneath this. But when we're done, let's say I just want to look at the first 5 elements of these lists just to verify that we have something in there. And we can absolutely do that. And in fact, we can simplify this down just a little bit more, because we can take this dot strip and put it right there, because we're chaining this along just like we did before with our column names. Now if we run this, we have a lats and lons element for every single row in this table. Now remember, we could only do this because we removed any null elements in this column by when we ran drop NA earlier. So we lost about 6,000–7,000 rows just because they had null values in their coordinate. So location, what we renamed coordinate, had less non-null values in there. Now, if we had a null value in here, still, we would get an error because it would actually come up as a nan object, and we can't strip or split a nan. Okay, so now we have our lats and lons. We need to take these lists of coordinate values and add them into our table, our data set here. So all we need to do that is, just like when we create a new value in a dictionary, we have to use this latitude. So we do OPD brackets key value of string latitude, and we can set that to lats, and we can do the same thing for our longitude. And now that we have this data, there's one other thing we can do, which is to drop our old coordinate column, because we don't need it anymore. And just like we did before, we can do opd.drop columns and give it our coordinate column and run it in place. So now, if we do opd.head again to take a look at our data, and scroll over this way, you'll see that we don't have coordinate anymore, but we have a latitude and longitude column with float values.
Scroll back up.
Yeah, there we go. So go ahead and make sure you have this in there. Yes?
Just for fun, I've been trying to check the type of each one of those lats and lons.
Mhm.
Since we have it in the database, or even if it's not in the database, the array, I guess, show us how to, how to look for the type. I know that it's not the type float that we need, but this is what it is.
Yeah, so if we want to double check that everything in that column is of a certain type, the nice thing about pandas, if we just look at the elements in latitude, it will not only will it show us those elements, it will show us the type. And if it's anything other than object, in this case it's float 64, means every single element in that column is a float type.
And if it's not, it will say like next or
Yeah, it would likely say object. Yeah, so if everything was a Boolean type or an integer, it would say that as well. So, yep, there we go. Yeah, I don't want to leave anyone behind.
Do you have something set up in your Jupyter notebook so that it limits the output? Because when I do the same opd.latitude, you get a lot more lines printed out.
Let's see. Take this off for a second. I haven't done anything special to it. I'm sure there's a big variable somewhere, but it's not breaking the code.
Yeah, definitely makes sense.
Yeah, no
In
problem.
terms of industry application, so this is good, clean, readable, understandable code. Avoid any list comprehension.
I personally use list comprehensions quite a lot. It highly depends on how long that line is and what the use case is. There are people that are for and against just about every aspect of a language, it seems. But as long as it is readable and people can understand what you're getting at, and it works. If you have those two things, then you have good code as far as I'm concerned.
Is there a way to just run all of the commands over again?
Oh yeah. So if you get totally lost and you just know that all of the elements in your notebook, maybe you overwrote something like we did before with the column names. If you go up to kernel, you can interrupt any kind of code execution. You can restart the kernel. You can also do restart and run all, which if we do that, it's going to run through every single one of our cells sequentially. So, yeah. Anyone still getting this down?
So back in our computer, this is editing the CSV file.
So we really?
I don't know, is it?
No.
Where's all
So
this getting stored?
so currently, all of this is in memory, and in fact, if you want to see the current the memory size, in that info call that we saw before, if we run this again just down here for the sake of argument, we can see currently this is taking up about 15 megabytes of memory, but it's not written out yet. That's going to be the last thing that we do. Just as a yeah, but then you would just you would just need to run the notebook again. As long as all of your code works end to end, you'll be fine. At the very end, the last thing we're going to do, and you don't need to write this just yet, is we can do write CSV, and then we can just give it clean opd.csv. So that will be the last thing that we do with this data, is actually writing it back out to the disk.
How do we save our notebook file?
Command or Control S. You'll see that there's unsaved changes on the top next to the name. Do that. It's now saved. And if you want to rename this to something different, you can just click on the name up there and title this OPD crime cleaning, just whatever you want to call it. And back over here, you'll see that the name is updated there as well. Oh, and if you see the green notebook there, that means it is currently open. So everyone have this down? We can continue on? All right. So the last thing that I have, let's get rid of this. Last thing is looking at this timestamp. So we can read this, but it's not all that useful from a computing perspective, because we would rather this be in our standard computer and database friendly timestamp format. Well, there is a wonderful aggregator function that we can use, or you can do, let's actually take a look at just what the output is. So there's a pandas toDateTime function here that we can give it our timestamp data, and then just for the sake of showing it, we can print off just the first couple. Now this, because we give it no other information than this is a timestamp I would like for you to look at, it's going to be a really slow function. But what it is doing in the background is figuring out on a row-by-row basis what it needs to do to convert that text into a timestamp for us. So it can look at this and go, well, I see that this row means that this is supposed to be February 19th, 2013. And in fact, if you look at the output right here, this is 2013, February. And it can even do, let's see, so 10 p.m. puts it to our 24-hour time format 22. So it did that without us telling it what to do explicitly. However, it did take it took much longer than all the other things that we did in here. So to make that faster, as long as the format is the same for every element in the column there, we can actually make it faster by explicitly telling it what the format is. Now, because we haven't looked at this, and even I still need to look at this table from time to time. There is a standard syntax for specifying a date time. Here we go. Here we go. So when we create a string, we know the location of the elements that we want our formatter to convert. So this percent uppercase y represents in that string we want to parse a 4-digit year, and a lowercase y is a 2-digit year. Where then we have other things in here as we're going to use uppercase M for minutes, 0 padded. The weird one in here I think is lowercase p, which is locale's equivalent of AM or PM. So the way that looks is if we copy and paste this string right here, we can go through and replace each one of these elements with those percent character, so we can tell exactly what we need to do. So that 02 is a 0 padded month. I'm pretty sure it's going to be an M of some variety. So lowercase m, month as a 0 padded decimal number, that's exactly what we need. So we replace that with percent lowercase m. Then for our day, that's a percent lowercase d. And as we saw before, our 4-digit year is percent uppercase y. Then we then for our hours, it's not uppercase h because that's a 24-hour. We are using a 12-hour, so we need uppercase I. Then we have our minute is an uppercase M, and our second is an uppercase S. And then the AM PM is a lowercase p. So, oh yeah, that's not the first time, that is not the first time that I've done that. Good catch. So this datetime string represents the generic format of every timestamp that is currently in our data set. So if we rerun this again, you'll notice it was much faster. Much faster. And you also notice that our D type down here is a native date time. So all we need to do here is we can't use in place in this because this is a pandas or a higher level pandas function. We're calling PD or pandas.toDateTime as opposed to OPD. So we need to apply it back to our timestamp column. And now if we do opd.head, we'll see that our timestamps are now our standardized date times in there. So, yeah.
So you went back and added OPD timestamp.
Yep. Here's the important line. So opd.timestamp. And then the only character that's off the screen right now is that closing parenthesis. Question?
Where did you look up all the time codes?
Oh yeah. So if you just do a search for Python datetime, it's the only way I remember how to get to it. This is the official Python documentation. Just make sure that you're in the right version. Just probably anything but Python 2.7 should be fine. And then they have a lovely little link, strf time and strp time behavior, which will take you right down to that list. This is also standard, so you don't need to go directly to the Python documentation to find this information. But this is going to, in most instances, this is going to be more accurate in case there were any quirks that came up. Yes. Yeah, remember, it's not OPD, this is PD, which is our pandas shortcut.
Syntax.
Oh, you're just missing a comma after opd.timestamp.
You're right.
Yep. So everyone good? They've overridden the timestamp column? Okay. So
No. He said it didn't show up on the screen.
For the data that we're going to be loading into the database, does it matter what format we're doing these timestamps in? Like, should we try and do like GMT time or Unix timestamps, or is there like a good?
So this to date time there, this when we export the CSV, it should export as a Unix timestamp, a standard UTC Unix timestamp.
Okay.
Or not UTC, what's the?
Is it GMT or ISO or something like that?
ISO, that's what it is, ISO format. So at this point, we're done with any with the changes that we want to see in our data set. This is a clean data set now. Is anyone else think of something that maybe we want to change in it? This is kind of spitballing here.
Do we need the block off the address?
So
It's not,
yeah, we're not going to map using the address. If we wanted to map something, we have our latitude and longitude coordinates. And again, because this is crime data, they're not going to put the exact address in there for privacy reasons. So they're not going to give us, it's 8651 Andreas Ave. They're going to give us 8600. So there's however many locations in there. Yeah. I've done analysis on OPD data before, and it is much easier to actually do the latitude and longitude, bin them together, and then treat that as a unit. If you bin a whole bunch of the latitude and longitudes together, and put that on make a heat map of it, it is interesting. Some of the things you find, like you'll find that a lot of entries in a dispatch data set are going to be responding to crashes at intersections. So every major intersection on your heat map is going to be very bright red. Yeah. I had a fun anecdote of when I initially put out that that data analysis, that within a year, every single one of the intersections that had the top 10 or so number of police dispatches, aka responding to a crash, all had red light cameras on them. And in case you're wondering, the most dangerous intersection in Orlando is is Vineland Road and Kirkman, over by Universal.
Do you know how they sort their CSV file? Because the date is obviously not by date. You have 2013, 2014, 14, 16.
Yeah, I don't think they did any sorting.
Oh, okay.
We could try to do some sorting. We could do sorting on a date time.
That's kind of strange. It's not a case number. It's not
Yeah.
a date.
That further scrambles it.
Nothing that a little dot sort would fix. But so one of the other libraries that we installed earlier. Oh, question.
We could change offense charge type to binary values since it comes out as committed or attempted.
That's true. So offense charge type, I believe there are 4 values in here, and we can verify that by doing opd dot offense charge type dot unique. Oh yeah, so there's only 2 in there. So we absolutely could make that. We could convert that to a Boolean value, saying, committed, or if we were prepping a data set for machine learning, instead of using categorical data, because a machine learning algorithm doesn't necessarily know how to utilize categorical data, it uses something called one-hot encoding, which means that if there are two possible options in a category, then you would split that into 2 columns where it's was committed, was attempted, and if it's committed, that's true, false, and do that. Except it would be 1s and 0s for machine learning. But we absolutely could do was committed or was attempted. Now we could split that into 2 columns, or we could potentially lose that information, saying if the column is committed true, well, what was the other option?
Right.
So, and for the sake of this project is putting the data into a database, we can keep the strings as is. Maybe we make them lowercase or something like that, just for standardization. But doing the one-hot thing, it would be, if I'm making this specifically for machine learning, I would make all my categories one-hot. Or I would say, if we were trying to predict whether something was committed or attempted, we would even just separate that column out, make that true and false as, was it true, was it false? And for that, we probably would take out address, because address, we can't really use address for that. But then we would do one-hot encoding for location type, offense category, offense type, things like that. Now, one of the other libraries that we installed earlier is called matplotlib. And that is your granddaddy charting library, graphing library. And we're not going to use it directly, but there's this lovely bit of syntax that pandas provides us where we can very quickly make graphs just by accessing our various columns. So in this case, if we want to just get a quick visualization of how many committed versus attempted ones we have, we can do opd.offense-charge-type.plot.bar, and I believe that's a function. No, okay, so maybe this. So I forgot something. We need one thing in here, and that is to actually make the counts. So this bar chart doesn't really know what to do with a series of text information, but it does know what to do with a list of a string occurred this many times, and this string occurred this many times. So in order to do that, we should call up our value counts. Now, just to show that off, I'm going to remove the rest of this, just to show what this creates. So we can see that in our data set, there's about 9,000 attempted, and the rest of them are committed. Yes. How competent were they? And just copy this down here. Now we can take that information and we can make a bar chart out of it. Ta-da! Super easy visualization. Well, if we wanted to do that to anything else, let's say that we want to do the offense category. So instead of offense charge type, we do offense category. I did. So there's a whole lot of theft. In fact, theft is half of everything that we have here. But you know a really great way of seeing that data? Well, we can just make another bar chart out of it. So, whole lot of theft. You know, a very large drop down to burglary, assault, narcotics, fraud, and bribery all the way down here. Doesn't even, you know, these don't even have enough to get a single pixel in this.
Do you technically know what's the difference between robbery and theft is?
Well, apparently it is not common, or it's only common enough where it occurred once in our entire data set.
Talk to my robbery. 4,000.
I believe.
One's a business, one's
Yeah, I believe.
from your backyard versus
Yeah,
somebody who's in.
I believe the technical definition or distinction between robbery and theft was a person in bodily harm. So if you are held up at knife point, that's a robbery.
They break into your house while you're asleep.
Yep.
They'd also be breaking and entering.
Okay. And then we can also use our lovely deer here. Like I'm just going to do plot, and if we wrap this in deer, we can see all of the different plots that we can make from this data. So bar was one, but we can also make area graphs, box density, histograms, line plots, pie chart, scatter plot.
What's a hex bin? Have anything with hexadecimal?
I do not know what a hex bin is.
Control the colors.
So
There's no
you might have a little bit of control with the colors using this method. If you really want, if you want to make some real nice graphics, there are libraries like Plotly. If you're not familiar with Plotly, it's mostly online, but they do have a Python library you can use. If you want native Python, you can look at a library called Bokeh. Bokeh or Bokeh, people call it different things. But one of the nice things with Bokeh and some of the other graphing libraries is you can make interactive visualizations inside of these notebooks with sliders and everything else. It's really nice. Yeah, it's a little more involved than what I was planning to do for this workshop, but we still have 30 minutes before we hit our break, so we can look at making one of these if you guys want. So let's actually take a look at Bokeh here.
I can make your map for a specific category.
Yeah, wonder.
Vehicle theft map. Know which roads. Carjacking.
So, trying to remember. I'm actually going to reference in a little bit of my code in order to, yeah. Like, if you've written it before, you might as well. There we go. Oh, this is actually using D3 in here, but it's not quite what I was going for. But this is a more JavaScript-based example of loading this in, and I haven't touched this in a long time. So I think we could click on an element and it would show parts of it. Or there we go. So this here was a person robbery, violent. There's the time and approximate coordinates. It's cool, not what I was going in here for. EDA, that's what it was. So this is actually just taking a Jupyter notebook, exporting the HTML, and you get this lovely little thing in here. I forget what library I was using to do this.
Was that previous page, does that have a picture of you on the front?
Yeah. Yeah,
Is that maybe a guy that just looks like you? Or
no, this is my website.
Okay.
Maybe it's on GitHub. I think I exported it not showing all the code, just the stuff afterwards. EDA stands for Exploratory Data Analysis, by the way. Oh, I know why, because that was in R, not in... Okay, never mind then. Want, want. I think this is more along what we're looking for. So let's see if we can get one of these up and running. I think I have Bokeh installed, but yeah, they're just doing a random fill here. Okay. So I'm going to copy this in there, and instead of creating these random lists of things, we're actually going to use our latitude and longitude columns that we created. So, oh, no, I don't have it installed. I'm going to shut down my kernel here for a second. Pip install Bokeh.
How do you have to shut down your active Jupyter session?
I would say it's safer. I'm not sure you need to. Okay, and load the notebook back up. Okay. Right, so now that we're back in here, we can do restart and run all to get us all the way back down to our previous point.
Did you want us to install Bokeh?
No, this is we don't need to.
Fun example.
And whatever this file ends up being, I'm going to go back and use those markdown blocks to clean it up and do some annotations and say here's what we're about to do, and then push that to the code repository so that you'll have a working example that we can, and more importantly, a working database so that that's not a factor for next week when we start looking at Flask.
And that's to make it into a website. Flask.
All right, so now I have Bokeh installed. Great. Let's see, back on the reference over here, they're setting colors and such. Output to static HTML file. Interesting. Let's just see what happens. One thing, we are going to need to go in here and change our X and Y. Just put that in there as is. Oh, for our range, so they're setting a range between 0 and 100 for their sample data. Let's figure out what the range of our coordinates are. So let's insert a cell here. Do pandas, column, range. figure out what the thing is for it. Oh, I bet it actually picked up on the range function, not. They have min-max on the column values, but I wonder if there is something different. Nah, let's just do min-max. So we can do opd dot latitude dot min. So that's our minimum value there. Let's do. So actually, if we just want to keep this in the code here, so our latitude is north-south, so that is our y value. So for our minimum value here, we can do opd dot latitude dot min, and our max y value is going to be opd dot latitude dot max, and then we can do this. We just do the same thing over with our x's there, except with our longitude. And for clarity's sake, I'm actually going to put these on different lines. Okay, so this is setting up an initial figure with the ranges found in our actual data set here. Then we need to add a circle renderer with, so our x values here are going to be our longitude, and the y values are our latitude. I'm still just hoping that this is going to work. So they have radii and fill colors. I don't believe we need to worry about that. Let's see, radii, yeah, random. Yeah, I think we can just get rid of those two. It's not going to look as pretty. Hey, that's pretty cool. So let's zoom into this. Whoops. So in theory, we can make one of these and then have, instead of the backdrop be white, we could have everything sitting on top of, say, a Google Map or OpenStreetMap's image, and all of these dots here representing our crimes would stay in the same spot, overlaying that spot on the map. That's in a similar fashion to what we saw before with that earlier project. I just want to pull up, I can pull that back up again just to show an example of exactly that. I think it's just way towards the end. Yeah, right there. So, an example of exactly that, except instead of having individual dots, these are actually binning everything together into a single pixel and then putting that on there, just shading it differently. I have a different map. Here we go. Yeah, that would be something that you would do there. This is the example that I mentioned before, where these are just filtered by accidents for instead of crimes, this data was based on dispatches. So whenever an officer was called out to a location, and you can see down here, everything on Kirkman, especially this one right here, is very dark, and they all have red light cameras on them now. Also very interesting, you're far more likely to get in an accident on Friday if you leave a little early from work. That was another fun thing.
Seems like that'd be after a couple couple hours for happy hour.
Yeah.
Are you able
About
to
7 o'clock.
do like queries or filters on the data set from pandas and Jupyter?
Yeah.
Let's say we want to look at, murders committed on a Friday or something like that.
So, trying to think of how to do the Friday one.
Or, I guess, on a certain year or something like that.
Yeah. So,
Look up Christmas. Murders on Christmas.
In-laws, family dinner.
so do. I believe all we need to do for that, I'm going to take a look at the head again right here. So let's say we want to look at just assaults in our offense category here. So we do offense category. And if my memory serves me correctly, oh man, this has been so long. OPD actually might be OPD dot offense category equals assault. Okay. Yeah, so this is, so we are taking a subset of our OPD data set where the filter OPD.offense category value equals assault. And we can chain these together. So we can also say, now I want to take another subset where the offense location type happened at a school. And so now this is just all assaults at a school. I'm trying to rack my brain of how to do the date-based query. I believe if we wanted to do that, we should be able to do something like if we import date time, because remember, all of the elements inside of our timestamp column are native datetime elements. So I'm going to do from datetime, import datetime. So I would be able to do something like, let's say our xmas equals datetime of year is, let's look at Christmas last year, so 2018, month equals 12, and day equals 25. And actually, I'm going to rerun this again to import a time delta as well. Okay. Now, I should be able to do something like OPD, where we again look at our offense category is an assault, but then we also subset it saying that your the OPD.timestamp. Now, equals here is probably not going to return anything because nothing exactly equals just midnight exactly on December 5th or December 25th. But what we can do is we can check if our value is between our days equals 1. So this expression right here, xmas minus 1 day, is going to be checking if any of our timestamps are greater than December 24th. And then we can add another one that also says is also less than the day after Christmas. So this is effectively going to say your timestamp must fall somewhere between midnight on December 20th, or I guess this would be midnight on the 24th, but not exceed midnight on the 26th. So this will probably bring up 2 days, but I'm still not even sure if this is going to work exactly. Value of a series is ambiguous. So I'm actually going to...
You go back and redefine your timestamp.
Would you even need that minus time though to that? You could just make that first one Xmas and then have the plus on.
Well, for the sake of simplicity, we can, I believe, if we just did that, everything, all our timestamps that are greater than the day before Christmas, this would give us everything. Yeah, that doesn't quite work. Okay, interesting. So there's no data in here from after Christmas of this past year. So it was actually working, kind of, sort of. Yeah. So this actually did work. I wonder if I can still do this greater than bit there. It might have just been complaining that it was ambiguous from the greater than with the minuses in there. But we can change this to a different year. Okay, no, I guess it is complaining. Okay, so this would at least give us a date query saying give us all of the rows in here that have occurred since Christmas of 2017. And then we can put our assault query back in here. So if it will let me. So these are all of the assaults that have occurred since Christmas of 2017. Right. Okay, so yeah, it's close enough for a break. So the last thing that we need to do, and I alluded to this earlier, is now that we have this clean data, we have an idea of what it looks like. We can export it back out to a CSV by doing, I believe it's PD, not OPD. Actually, well, let's see. I'm still fairly certain it's PD instead. Right, CSV, clean OPD.CSV. Yeah, okay. It is pandas, and we give it that arg.
It's 2 CSV.
That's it. Thank you. 2 CSV. There we go. So back over here, we now have clean opd.csv.
Oh, I need to see that command again.
Yep. So we have our dataset.toCSV, and we give it a string that is different than the string that we used before to load the dataset in. So we have the original copy, and we have our clean copy.
But it needs to be the same name we named it instead of clean. If we had uppercase clean OPD.
You can name it whatever you want.
Okay, this is renaming it. Gotcha.
Yeah, just as long as it's different so you're not overwriting the original one. If you overwrite the original one and try to run this file again, you're going to get errors because we've gone in and changed the data. So it won't run the same. Question?
Not really related to that, but just for my reference, can you go back to the page? How did you get to the color scatter plot?
Oh, yeah. So when matplotlib is installed, we can do these .plot.bar. So this is representative of. Are you asking about the? Okay, for the Bokeh library. Okay. So that's what we used.
I wanted to see where you got it from in their website. Like,
Oh yeah.
This is like
This is just the quick start guide.
quick start.
Yeah, if you do Boca quick start, we just adapted some code from their guide here. So I'm going to figure out how to put Boca, the Boca output into the notebook for the time being. But once that CSV is written out to your disk, take a break. If you don't, for some reason, don't have the same thing, you can download it from here. I will copy and paste this into the meetup description right here. And actually, let me just link direct to the file, because everything from today is going into this data repository. Clean, OPD. So let me paste this into here instead. Okay. So if you need to download it, go to the meetup page. It should be the second comment in there.
Go back to your,
Yeah, and
got extra G in there.
and then all you need to do is click download, just to make sure we're all starting from the same spot. And if you haven't done so already with the pip installs that we used earlier, make sure you have installed SQLAlchemy. That is what we're going to use to create our database. It installs it into the environment. So if I were to run this right now, I'm using Anaconda in the base environment there, so it would install it into that. Whereas back here in the thing that's running Jupyter Notebook, I have it running in this WS environment, workshop environment. So if I was in the base and I installed SQLAlchemy into WS, I wouldn't be able to access it. But it does mean that as long as the terminal you are running in is using the WS, the workshop environment, you can go to any other project there and it has access to the same Python libraries. It's not like Node where it puts all of the Node packages into the project folder. So help out your neighbors if they are getting stuck.
The download button, should it start showing the whole database, or should it just download a zip or something, right?
Well, let's see. Yeah, you should. Yeah.
Well, that's what downloaded the whole database. Yeah, I thought
You could also
like this, and then I click
select all and put it into a file.
Michael, did you mean to
we can't
make
show
the
it, that's
CSV?
fine.
Yeah.
Download it.
Mhm.
Right, okay.
Yeah, that will take you right to the CSV page.
I was just trying to take notes.
Oh, you can if you want all the code, then you can also just go to the main page there and download the entire zip directory. That will include everything we've done so far in this workshop series. Yeah, so this is on GitHub. If you just do clone or download and do download zip from the main page, so yeah, click it on there. It'll download the entire thing.
Overwrite, replace. So if we replaced it wherever we stored it, is that automatically going to find the new one in Jupyter if it had the same file name?
Well, we're not using Jupyter anymore.
Ah,
Yeah,
doesn't matter.
so we're gonna open up our file editor again, like we had from
So we can
from
close
last
out
time.
Jupyter.
So, in fact, if you do download the entire project file or the entire GitHub project in here, the repository, you can open up that entire thing in a code editor. So VS Code here or whatever you are most accustomed to, because we'll be working in our file editor again. So as an example, here's our.
So we should probably open a new terminal.
I'm sure I have something that makes these look nice. Rainbow CSV. Yeah, okay.
I'm guessing you didn't send it with the Excuse me? Are you Greg?
Yeah.
Okay, thank you.
So we should open CSV file.
Yeah. So we can see the information that is in the CSV file here. What we're going to want to do is wherever we can access that CSV file, we can create a new file and we can call it models.py. So
you said just to open up the entire zip
I
file
got it
in
listed,
VS
yeah.
Code?
yeah, so you can do that. That's going to be the easiest thing to do, in my opinion.
What are you trying to do?
Then we're opening individual files.
Oh, code? And then the name of the file.
Yeah, sorry. Just trying to see the.
Opening it?
I think I have to download that file.
If you're using, you need to unzip the repository, and the easiest way to get into it would be to open up VS Code here. You can do open folder, and then navigate to wherever that unzipped file folder is, and click open.
So are we not working in Anaconda?
Well, we're not working in Jupyter Notebook anymore. Yep. VS Code or whatever text editor you prefer. Yeah, you can use Spider. Oh, yeah, Spider does come included with your Anaconda install. Mm-hmm. Yeah.
You mentioned a zip file?
Oh yeah. So if you want to download the entire repository instead of just the CSV, you can download the zip file there. We could, but we're only going to build out one table for here, so there's only one model. If you had a whole bunch of models, if you only have a couple models, you can put them in the same file. If you have tons of models, then yeah, you could have a models folder and then user.py and Pokemon.py or whatever. I'm sure they're doing something with it internally. They are uploading certain types of data for transparency reasons and things like that.
Probably trying to predict high crime areas so they can schedule patrols around there.
They probably have reporting requirements to the state too.
Yeah. You don't need to make a data set public in order to submit it for the state, but this is just a nice thing for us.
Yeah. If I will, with the school system doing that, then you got to make sure there's nothing that connects to anything.
That's why it had the end block of Orange Avenue.
Oh yeah.
So does everyone have a file ready where we can start writing some code? All right. So the library that we're going to be using to create our database here is called SQLAlchemy. SQLAlchemy is what's called an ORM, an object resource mapper. That's just a fancy way of saying instead of designing our database in an editor somewhere like MySQL Workbench, we actually use code to design our database, to make any changes, and then the object part of that is in our code. Instead of treating data like a list that gets returned, we can treat it as though it were any other object in Python. Hey. Yeah, so it's going to make more sense when we actually start looking at it. But when we design our models, we design the models, and therefore we design our database tables as a class, which an instantiated class in Python is called an object. So object resource mapper. So if we want to access the ID of a crime in there, we would just do whatever my instantiated crime is .id, just like we would with any other regular Python object. So,
question, sorry,
yeah.
before you move forward. Does the models.py file need to be in the same directory as the...
It doesn't need to, but you as long as, just like with the notebook before, if it's in the same directory, we can just use the name of the file, as opposed to, if it were in the data directory, we could do that, or going all the way from the root. So the first thing that we need to do is actually define the connection to the database that we are going to create and or connect to. So I'm just going to copy this over because copy pasta never failed anyone. I'm actually going to name this DB. Now, Python has native SQLite support built into the standard library. And you don't need to have any database system installed on your computer to create and work with SQLite. It just creates a file that we can read and write to. So I believe we just give this let's just call it crimes.SQLite. So Okay, so let me make sure that actually works properly. Hmm. It should have created a SQLite database in here.
Is it, I mean, you have three, I don't know, but you have three of those slashes there. It's not like a URL type command. Those are all directories, right? So slash forward slash.
Okay, yeah, it actually is expecting.
Those slashes.
Yeah.
There's four of them now, right? Instead of three?
Yeah, this is an example that they gave there. I wonder if it doesn't actually create the database until you write something to it. That could also explain it. So I guess maybe for the time being, let's see if that actually. Yeah, I'll take it as running, and if we get an error later on, then whatever. Okay. So the first thing we need to, now that we have a connection created, even though we're not really using it yet, we need to design our database table. So let's actually do, was it model or not? Okay, base, that's what it was. I've been living too long in Django. Are you gonna give me an error? Yeah, I don't think it likes base there. I think it just wants that. Okay, so for our crimes information, the crime table. I'll actually pull up the head back over here. So we have a case number, which is a string. We have, let's actually go back all the way down to the bottom for our to see our final output, because that's what we're actually using. So we have our case number, which is a string. Our timestamp is a datetime object. Address is a string. These different location types and everything, they are themselves strings. Then we get over to our latitude and longitude. Those are float types. So if we want to use these exact same columns, for example, number and timestamp, we create a class of type crime. That's the name of both our object, our class name, and the name of our table. So for our column name was a number. Up here we imported a couple of database types that we're going to use, string, float, and datetime. So our number column, our number attribute is a string. Our timestamp is a datetime. And we copy, paste, repeat for the various column names here. So address, offense, location type. I hope it will, let me just do this. Cool. So address is string. Same thing with all of these. And remember that our latitude and longitude are floats. And if we were trying to optimize our database representation, for example, if we knew that a string for a particular field was no more than 4 characters, we would be able to give it an argument saying length equals 4. And then in our database, it's going to allocate space that's only 4 characters long. There's just some optimization items that are available from this ORM.
Is your spacing with your equals matter?
No, you can. You don't have to put. Yeah, it just is nice for readability. Oh, I should probably standardize that too. So for an object relational mapper, this is now our object, which is a native Python class. Oh, and there should be the base because there are other things that we need to apply to it. I'm going to scroll over this way for a second. Okay, declarative base, that's what we're missing. Again, don't have to actually do a declarative base when doing something like Flask SQLAlchemy or the Django ORM. So if you were doing Django, you would do db.model, but here we do base.
Can you elaborate on that? Like, what's the base, declarative base?
Yeah. So we are inheriting from an object or a class type of base. Base is what is actually going to take our crime class here and make it a database model. For example, we'll be able to do something like crime.create, give it all the information that it needs, and we have a new crime object. If we do db.commit, then we'll have a new record entered in our database, in our actual SQLite database.
Declarative base is that which allows us to do that.
Yeah. It's been a while since I've touched vanilla SQLAlchemy.
So this is more conceptually, and someone already may have said it, and I was just off in another world. So this is an in-memory database that you're building.
So,
Or is this, no.
Nope. So this is a file-based database.
But it's on the machine. It's not connected to an external source. You're
Exactly.
not inserting data, transferring data.
Yep.
Okay. But it has the capability of transferring data to that. Say I have a database somewhere else that I want to have it consume the data.
So the nice thing with these ORMs is they play nicely with all of the major flavors of SQL databases. So just because we are deving with SQLite here, if I actually wanted to put this on Postgres, I forget if you actually need to put Postgres. I think it's actually Postgres. And now it would be connecting out to a Postgres database, or you can do MySQL, and now we're connecting to a MySQL database. Now, obviously, you would want to do your user password at local host on whatever the port number is. But you don't have to change your code. You don't have to change the the models that we're creating. You just change what database you're connecting to.
And it also has the ability to connect to an external
Mm-hmm.
extract. To maybe somebody's staging a SQL Server varchar max, they're just loading a shit ton of data in there. You
Yep.
can pull it into Python to cleanse it and transport back out.
Yeah. Now, if you are connecting to an existing database where you don't have, or you're not managing the structure of that database, you probably would not be writing out all of these models in here. Is the big benefit of an ORM is that it allows you to generate and maintain the structure of the database in code, because then you can commit in code. You can commit code to repositories, to source control. You can't commit a database to source control, unless it's SQLite, but whatever. There is a wonderful little thing in SQLAlchemy and some of the other, and some ORMs, where you can, it will create a database model based on the existing structure of the table you want to read. So you can, if we already had a crime table in a database, but we just want to read it and interact with it as though it were a regular Python object, there's a command where you just do db dot like create model or something like that. You give it the table name, and now and then it creates a class for you, just in memory, that magically represents exactly what the structure is. So I've used that once before. It's not terribly recommended, but it's nice that it's there. It's pretty. I think it's pretty cool.
When you use the term model, so there's financial models, and then there's dimensional models, and then third normal form models. The word model, and when it's used within this area, within code, that's just that object's structure, right? That single table structure is what the term model is.
Mm-hmm.
Okay.
Well, and strictly speaking, from a data perspective, a model is anything that contains and manages data. If you've done any kind of web front end or back end, you might have heard of various architecture types, like model view controller, MVC. And that's just saying that there is an explicit separation between your models, your views, and your controllers. Or to translate that a little bit, your database entries, your HTML, and then the controller, which is your logic that connects the two. For example, you wouldn't want to use HTML or JavaScript on the front end to handle your database mappings. So the idea with an MVC is that these are distinct separations, and depending on the web framework that you use, they have various levels of enforcement of that type of architecture. For example, when you create a default Django project, you would when you create a new app, it will automatically create a views.py, models.py, a templates folder. So your views.py, even though it's called views, is actually your controller. And those are the actual handlers for, I got a call at this endpoint, let me call the data that they requested, and then pass that data to my templating engine, which is the view, because now you're dealing with the front-end HTML. It's more semantics than anything else, but models are just, in this realm, are just anything that contain and manage data, which, if we're going to...
Like if I'm talking to somebody and I just say it in the way I understand it and use the terms that it's good for me to remember, it's not going to come across. I'm not going to be able to verbally communicate. So yeah, the semantics are kind of important, to be able to communicate, hey, this is what I'm working on to other technology people.
It also depends on the context, because when you're talking to a bunch of web dev people and you say model, they're saying, oh, that thing that connects and manages my database tables, Whereas if you say model to a machine learning engineer, well, the model is the trained predictive algorithm.
That's all your audio.
Yeah.
I'm not quite sure what's going on, but I am trying to use Spider, so that might be like a syntax.
Make sure that, are you having problems on import?
Yeah, I think I'm having problems defining the class because the class does not have a table or table name specified. It's a Dunder table. I'm not sure if someone else is using Spider. Yeah, mine is not really one.
Is it able to import stuff from SQLAlchemy?
Yeah, I'm not having issues on that line. My issue is in defining the class.
So make sure you are. Let me pop over. Or yeah, that'd be easier. Crime does not have a table to specify. Let's actually look, because it's entirely likely that I'm going to get that error when I run this too. Yeah, so let's figure out what's going on with that.
Sorry.
No, that's good. Okay, so interesting. Again, this is not something that I have to do with something like Django. They have this this Dunder table name here. Oh, I guess we need to specify column too. Okay. And I'm very rusty on SQLAlchemy. So let's actually get this. Dunder table name crimes. We also need to import column up top. And instead of all of those, we need to do column of type string.
Column.
Yeah. This is why I love live code. I'm not some kind of coding wizard over here. Everyone makes mistakes, especially when you haven't touched a library in a long time. Let's see if that... Okay. Mapper, map class cannot... Oh, need ID as well. Totally forgot about that. Equals column. I bet they have, yeah, integer primary key. Double check. Cool, okay. So that works. Yeah, I ran it and it gave me no errors. Yeah, it's not actually doing anything. If you just run it as, run this as is, it's just verifying that all the syntax is correct and it's creating the object correctly.
Is the SQLite command at the top after create engine that like the database name that we?
The declarative base?
Yeah. Well, the string that you passed in to create it.
Oh, this right here.
Yeah, so that describes the database.
Yeah, it's going to create a crimes SQLite file once we commit data into it.
Okay.
Oh yeah, just Python space models.py. We're just running the file. So
This isn't the migration file, this is.
no, yeah, we're not doing any migrations on this. We might, we probably will next week when we look at Flask.
My VS Code is saying that it's unable to import MySQLAlchemy. Do you have a native one?
Have you installed it?
Yeah.
Are you in the? Did you install it into a?
In my terminal, when
Mhm.
we're supposed to do the installation.
Okay, so you're in base right now. What you're going, what I would recommend you do here is there are add-ons for VS Code here. Python is actually the most popular one. Okay, so it's already installed. If we're in models.py, there should. Well, terminal. So let's get out of it. Okay, so we're in base right now. Sorry about this. Okay, so it's there. Oh, hey, so let's make this actually use the reference the right Python. So there you go.
Thank you.
Okay, that's it. On the off chance you have multiple Python instances and you're using VS Code, if you're wondering why you maybe have some red squigglies saying you have a code error, on the bottom bar, it will say Python something or other. Make sure that, especially if you're on Python 2.7, make sure you select something else. In this, you can select base, or I'm already in my workshop, but this is how you can tell VS Code to look at a different environment of Python. There's a
If you click the word Python at the bottom.
yeah, click on the word Python. This is assuming that the Python extension is installed in VS Code.
But is there an actual different purpose for having the different environments?
Well, if you're working on multiple projects at the same time, you don't want your dependencies to conflict with each other, so you would have multiple environments for that.
So it's like having a different sheet in the same workbook type of deal.
Is SQLAlchemy a huge library?
15 megabytes, I think.
Gotcha.
Yeah, it's not very big.
I think it shows certain, but I mean in memory if we imported that.
Oh, no, it's not big.
Oh.
So I'm going to commit this in case anyone has this open and wants to quickly catch up. So this file is now on the GitHub repo. So continuing on from last week. From last week, can anyone remind me what this if name equals main does? Does anyone remember what this if name equals main line does?
It's another method that's looking for a main function, and if it finds it, it'll just pass.
Almost.
Almost.
Almost. We in a lot of ways we might actually do def main and then call main in here. Could do that. So this line of code, if name equals main, says that this whatever is in here will only run if this is the Python file that is being directly called by Python. For example, if I do print hello and I run python models.py, it will do everything and then prints hello because that was the file that was called. But if I open a Python interactive session here and I do import models, that code didn't run. But conveniently, while we are here, so we have our models.crimes object, or crime model right there. If we run a dir on our model here, so we have all the different columns that we gave it. So now we need to create a new example crime. Yeah. So this dunder table is exactly is our representation for what we are going to put into our SQLite database. There we go. Man, it has been so long since I've done just straight SQLAlchemy. Sheesh. All right. Okay. So, what we can do in here to actually create the table. Remember that we have this declarative base that we created up here. In our Python terminal, we can call. We imported models, so if we want to access that base, it's models.base.metadata. Create. So we do on models.engine because we have to supply the database connection. Oh, I didn't call it engine. Call it DB. Copy pasta. Yeah, but you'll see now we do have this. Yeah, I really do not like the way that they call that. So
you don't need that. The colons was to tell it to do it in memory.
Yeah. So for the sake of keeping this around, I'm actually going to change that to crimes.SQLite. So let's actually, well, I'm actually going to put this stuff in here just so that it gets created or put into the code repo. So we do base dot, I think it was metadata. Yeah, base metadata dot create all, and then we give it our database connection. I'm going to put a comment in there saying create tables. So we're just going to run this once and then we're going to comment it out because we have already created our tables. And I changed the name up here so that it's going to be an actual .SQLite database. So run python.models. Yeah, so crimes.SQLite down here. And I'm going to delete this. So we now have we now have an SQLite database file on our system that has a single table in there called crimes with the structure that we gave it in that class. Now what we can do is we can create an example crime. Before we look at any of the other stuff, let's just make sure that everything works. So to create a brand new crime instance in this table, we just create it as though we were initializing any other object in Python. So we can say has an index of 1, and let's actually take a look at, so it has an ID of 1, the case number, we can just call that. We actually do need to have our datetime object in here, so from datetime import datetime, because remember, native datetime column. And for simplicity's sake, we can make that be UTC now. And that's just a simple handler function that says what is the current time as a datetime object.
One question.
Yeah.
I seem to remember that in the past, or somewhere in my mind, we had like an dunder in it so that we could specify what would be needed.
Yep.
Do we want to create one with everything absolutely all the time? Or?
So the nice thing with this is when we extend from that declarative base, it's already handled all of that for us. We are calling that init method, but we didn't need to write it ourselves. Okay, so now we have 1, 2, 3, 4, 5, 6 string columns. I'm just going to give them repetitive values for time's sake. So 1, 2, 3, 4, 5, 6. And then we have float values for our latitude and longitude. So let's just give it that and say, yeah, let's just do -11. We can print out our crime there, and we'll just leave it at that for now. So we try to run this again, and we can comment out the line that actually creates our table there. Takes one position argument. I bet it takes a, bet it takes a something. Oh. It doesn't want positional. It wants key value. So all key value means is the different column names that we gave it, we just need to use the column names. And I'm going to put a bunch of new lines in here so it looks cleaner. Yeah, so if we omit all of these in here, those will just fill with null values. So we can just do latitude equals that, and longitude equals that. And that should work. Okay, so we now have a crime object there. Anyone remember what method we write with our classes to change how it gets printed out when we use print? It's a little not the best way of saying that. Not format. So in our class definition up here, instead of having this main.crime object at location in memory, that's not that useful for us. So we can add, or actually we can overwrite this def dunder repr function here, and only takes self, which is the object's reference as itself. And we can return a formatted string of crime occurred, crime occurred at self.timestamp. I believe that should work. So if we run this again, so we have an object here where the crime occurred at 3 seconds ago. And by the way, we should also be able to set default values in here. So you could say default equals, I'm also forgetting the syntax of exactly what it is, but most ORMs would have something like the default value of a datetime object should be whatever the current time is if one isn't given. So you can set default values like that. Conveniently, however, with the clean CSV that we created, we have all the data for every single row that we need. So we don't need to worry about default values. So we have an object, but it's not in our database yet. When we create a new object, if you're familiar with database connections, you always need to commit your changes. So it should just be db.commit there. It could also blow up in my face because I'm thinking about Django or something else. Okay, engine has no commit. Man. Okay, they're actually asking for a session. Yeah, it's all coming back to me. All right. Okay. Okay.
From daytime.
Right. So down here, we can declare a session which connects to our database connection. Now, once we create this crime, just creating crimes all day. Even better, we're committing crimes all day. It's great. We can also delete crimes all day. But we need to take our session object, we add our newly created crime to it, and then it should be session.commit, if memory serves me correctly. Oh. Oh, okay. Session maker, an instantiated session. Yeah, I think that does it. Okay. So this session maker is actually creating a session class, and then we need to instantiate an actual session. So this is their quick-ish start guide. I'm going to put this at the very top. So, and I'm also going to make plenty of comments later on after the workshop. So you guys, when you go back to see all of these files, there's going to have plenty of descriptions of what each one of these things is doing. As long as we get something working, it's good, because we got 45 minutes left. Let's do it. Okay, so we've gone through all of this, and probably if we rerun this again, it's going to say, well, a primary key of ID equals 1 already exists, because we successfully committed a brand new object into our crime table. And I believe if we want to see what is in there, there should be an extension in here where I can just open up SQLite files. Yeah. So let's have this install. Great. Okay, now if I select crimes.SQLite, maybe, nah. New query, no. SQLite Explorer, okay. So all the way in here, you can see that we do have, so we have our SQLite there. We do in fact have a table called crimes with the structure that we specified for it. And if we click this arrow, here's the crime that we created using our code, including those null values where we did not specify any data. So we have an actual working crimes database here. And we were able to successfully create a new instance of a crime, commit it to the database, and have it save it. So now we need to apply this to the data that we created, our clean data set from our CSV file.
Can you go back to the session? Yeah, session maker.
Oh yeah. So yeah, we have these. So another way that, or maybe a little more clear of what is actually happening here is this session maker is creating a class called session. And then our lowercase session, which is an instantiated object of that class, is the session there with a capital S, using those Pythonic conventions. So I'm actually going to take all of that and put it into a function called demo here. Yeah. So I'll leave that right there for you all. All the way up here.
Yeah, we have. Oh, so we.
Did the project that created the database, did they create a front end for the officers to like enter the new, like when they have a report of a crime, how does it get into the database?
Yeah. I don't know. I know.
They had to enter this manually in a CSV.
Well, they need to enter it manually somewhere, and it probably is some kind of old-looking police database, government contractor sort of thing. Yeah. Okay. And I'm going to commit this and push it up to our repository as well.
You know, DOS, I found myself using that recently. I merged a couple of CSV files in DOS because I didn't know, it was 2,000 files. I scrubbed with VBA and I was merging them. Like, how do I I'll just use DOS. I merged them all together in one file. It worked. I mean,
it worked. Okay, so we have our demo script here. Now we're going to create our populate from CSV file. So, so this function is going to take the file name of whatever CSV name we created before. So the first, let's assume that we're starting from a fresh database. So we would still, or a fresh non-existent database. We would still need to do our metadata create all function here. And in fact, if we wanted to make this even more clear, we could create a new function called create tables. And then at the beginning of each of those, we just have create tables call, and run this. But for the sake of getting this up and running, I can just do this here. We still need to have a session connected to our database there. But instead of going through and instead of creating just this crime information here, let's make sure we can actually read in our information from the CSV. So Python does have a native CSV library. We can obviously do open a file and then read line by line and split on the commas. But the CSV library does some extra handling for us, especially when you get to more complex CSV quotation handling. Let's see, here we go. So import CSV, and we create a CSV file here, csv.reader. We give it the raw file, and then we can iterate for row or for crime in our CSV file. And the way that would look in here is up top we can do import our CSV. So our file we can do with open our file name, and by default it's read as you call it crime data, or fin as in file in or falt as in file out. You'll see that often too. We can do here we can do crime data equals our csv.reader. And just in case you're wondering, there is a csv.writer if you are building a CSV. And our reader here, the first thing is an iterable, which in this case is our file. And looking back here, our CSV file, and we can add other things. We have, if you, yeah, we're not, I don't think we're going to have to worry about that. So we can just pass in fin. Now we have crime data, so we can do for crime in crime data. Let's print out the crime, and we'll break for now, or actually since we're in a function, we can just return. Because whenever you hit return inside of a function, that's it. So in either case here, either one would work. So if we just run this, and I am running without calling this information here. Oh, and let's actually make sure, let's actually call it down here in our main. So our populate from CSV, and the CSV that we are using here, I have it called clean_opd.csv.
Michael, sorry to interrupt. Did you ever remove the code for creating the one ID crime, or?
Well, we moved that into a separate function. So this is a demo, and this code is no longer being run because we're not calling demo, or at least we're not now. If we run this again, here's all the, well, actually, this first one is just the header information. So there should be a CSV reader thing to ignore the first header files. It might just be called headers. Alternatively, because this is an iterator, this is kind of cheating. I can call next on crime data, and it's going to skip that line. Let's see what happens. There we go. So here's our actual first line of data. So the way that iterables work in Python is they don't necessarily keep track of all of the data in memory. Maybe they just reference something. When you call next on an iterable, if you're starting at 0, it's going to return whatever the next element of that iterable is. But that iterable retains the current index that if you called next again, well, now it will give you the next thing in that row. Because we have not iterated through our crime data yet, calling next on our crime data essentially removes our first row, which is just the header information, from our for loop. It's kind of cheating, but I can't think of an easier way of skipping the header information. And you can see that the first time that we print crime, we have our 0, all this information here. Now it's not casting all the information, so we will need to do that. Yep. So this is all we're doing right now. We're not actually we're not creating the table information here just yet. We're just going to make sure that when we load in the data from the CSV is exactly the format that we need to populate our crime objects.
For skipping that first line, use array slicing or slicing on the...
We absolutely could. Instead of doing this next crime data, if we commented this out, we absolutely could do starting at index 1 through the end. The only thing here is when we do array index or slicing like that, it creates a copy of the data. So when we call this next.crime data, we're not making a copy, so we're still being memory efficient while skipping that line.
Can you put it at the line before it? But same sort of problem, but you're not keeping it around.
Like moving next?
No. CSV reader bin, and then do the array slice up there. So crime data equals that array slice, and then that would skip it. But it would still...
It's true. It would still create. It wouldn't have two copies. It would still, here's the copy, and then in order to do that array slice, even though it's on the same line that I loaded, it's still creating a new thing. But then it immediately gets rid of the other one because nothing is referencing it anymore. So, for memory management purposes, and just kind of, next does the job. And I only started using that particular syntax maybe in the last year. So anyway, so we have our line here. Now, if you remember from our table up here, our ID needs to be an integer. So we're going to need to cast 0 to an int. This is a string. We're going to need to convert our timestamp here into a datetime object, which we can use that formatter again, or we might even be able to use ISO format. I can double check that. And then we're also, the rest of these are strings, except for the last two, we need to take these from string into floats. So, and you'll notice that in our print here, we have square brackets on the end, which means that this crime object, this crime variable right here is a list, it's not a tuple, so we can overwrite in place. For example, crime 0, so at index 0, we're casting to an int that exact same element. So if we print out crime again, run this, we've casted this string 0 to an int 0 in place in that list. And we can do that with the last two. Anyone remember how we access objects at the end of a list? -1. -1, -2. So we can do crime, the last object in our list, and we're casting this to a float. Crime -1. And we're doing that for -1 and -2. So now these are both floats. They're no longer strings. Last thing that we need to do is to convert our timestamp into a datetime object. Now I believe we should be able to do something like, let's do crime index 2 equals, is it datetime dot, well, ISO format. Yeah, well, the thing here is that most of these things assume a regular datetime object and then converting to an ISO string. What we can do is this strp time. There's strf time and strp time. F is format, so I have a datetime object. If I call it strf time with a format string, it will export it as a string. Now this strp time is going to parse a string with a given format and return a native datetime object. So this strp time, I don't remember which is first, but we'll look at, let's do crime 2, and then the format for it is y hyphen month hyphen day space, see, hour, and these are all 24 hours, so we can use our uppercase H as opposed to the I, colon uppercase M, colon uppercase S. Save that. So if we run this again, there we go. So we've converted this datetime string into a datetime object with the same information. So this is all the parsing that we need to do, all the typecasting to make this line of data ready to be inserted into our table here.
Did it not take your seconds?
So, oh, it's just because the seconds are 00. So if it's a default value, that print isn't going to show default. So if we just gave it a date time of just 2013 and then 000 for all the times, it would just do 2013 and then not show anything else. Okay. Now actually, now that we have this information, if you remember up in our demo here, we had to do keyword parameters in order to create this object. Well, where do we think where are our keyword parameters? Or where are the column labels? They're our first line of data. So instead of skipping over this line now, we can say calls. So we can actually assign that first row of data to calls. And we're going to replace calls here with ID because, scrolling back up, our column list right here, it didn't actually have ID as a column header in there because the Panda data frame did not export ID. It just said, here's the row of IDs, but we don't have a name for it, so it's blank. That's all we're doing here. So what's really cool with this is there is a built-in Python function called zip that takes two lists of elements of equal length and says the first element in each list, that is going to be the, we're going to create a dictionary where the key value is the first element in this list and the value in the dictionary is the first element in this list. And it does all of that going down the list of iterables. So if we have crime equals zip of our columns and our crime data, and we print out crime again. Oh, zip object. I need to convert that to a dictionary for printing purposes. So we now have a dictionary of column value or column name equals this value for this particular crime. Now this is important because in order to create our crime instance, all we need to do is do this double star unpack, and this takes a dictionary and says all of the elements in this dictionary, these are now keyword parameters in this when we instantiate this new crime object. So we can do that. We print C. And at the very end, we now have a new crime object with the same timestamp as was in our data loaded from the CSV. I think it's kind of cool. Yeah. So I'm going to add I'm going to get rid of these print statements up here to make the print a little more, a little nicer. So first we'll print the column names. Oh, I need to do that before I overwrite crime. Okay, so if we run this again, we have a list here of our column names, and we have a list here of the values that those columns are associated with. Zip takes the column names, these become the key values in our dictionary, and these become the values in our dictionary. So the first element, ID, gets associated with 0. So in our dictionary, our dictionary ID equals 0. And you do that for each pair as you go along. Zip actually doesn't convert to a dictionary. It just creates tuples. And if you have in Python, if you have a list of tuple values of length 2, and you cast it to a dictionary, it magically creates a dictionary. So Zip isn't creating the dictionary. It's just, actually, if we, instead of casting this to this zip object to a list, and I comment this out because it's going to blow it up, you can see that we now have a list of tuples where those objects have been merged together. And we can add, more lists to this. So let's just say I want to add, for some crazy reason, I want to have crime multiple times in there. Well, now it's merged all 3 of those lists on an index by index basis into tuples. Just the nicety for our use case is if you have a zip object where the tuples, all the tuples contain 2 values, when you cast into a dictionary, it's now key value pairs, which are really cool. Okay, almost done. So this is the hard part. We've successfully loaded in a line of CSV data and created a new crime object that represents a row in our database. All we need to do now is reference back up in our demo script here. All we need to do is session add and session commit. And of course, we need to also uncomment these here. And for the sake of, so we're not going to return anything. And I'm also going to eliminate these print statements, just so we don't have tons of things being printed. There we go. So the last thing that needs to be done inside of this for loop here is we need to add this new crime object to our session. And then once we have finished dealing with our file, we then need to commit that session to actually push everything into the database. And to make it even easier, I'm actually going to delete our old SQLite database right there. So now, if we run this, so now that first printout is it created the table. It is now going through every single row in our CSV file, creating new crime objects, adding it to the session, and once all of that is done, it's going to run commit, and it's going to commit the changes to our database. It might take a second. So I believe begin means it is starting that commit, so it's already ran through everything there. Okay, now committed. So in our SQLite Explorer here, make this just a little bit bigger. So we have our crime table here. Now, if we look at the elements inside of this, loading, loading, loading. We now have the entirety of our CSV file represented in our database. So I think that's pretty cool. So I'm going, that is everything that I had on the docket for today. Do you guys want to see anything else with this?
Where could we find like all the good documentation for SQLAlchemy and pandas?
You can do what I do and just Google the name of the library. Yeah, whenever you can just do SQLAlchemy docs. You'll get documentation coming up right there. And whenever you see tutorial or quick start, that's always a great place to start with. So just doing the docs, click the tutorial, and that's the page that we were using to reference the building our table here. Do you guys want to see querying a database while we still have some time? Cool. Okay, so we have our database here. Now I can open up Python here and I can do import models, or actually even, yeah, I can do import models. Now remember, because we have, okay, let me get my file up here, models, okay. Now remember, because we called this in our main function, it's not going to run this again on import, which is great. But that means now it's imported, I have access to this DB, base, and crime object. All I really need is access to this models.db because I want to create a session here. So I need to do from SQLAlchemy. Oh, even better. Let's do this. I'm going to create a function called getSession, and it's going to create a session for us, so we don't have to keep doing that. GetSession. It doesn't take anything. It returns a instantiated session object. So now if I quit this, because whenever you make when you import a library, if you make any changes to the source file, you need to exit out of Python, the Python interactive prompt there, and reload it. And I'm going to do get session there so everything remains consistent. Get session. Okay. Save that. Now let's open up Python. Now I can do from models import get session because we can do selective imports from things. And now my session there, I can just call get session. Ta-da, we now have a session object. Cool. Now this querying over here, you can see that they're doing it's session.query, the table, or you specify the model that you're using, which using the table name, the dunder table name element in there tells the ORM what table in SQLite to query. So I need to go back here. I also need to, from models, import crime. So now we can do session.query on the crime table. And we can just call first right here. That should give us the first, yeah, so that's the first element in our table right there. We can call filter on it. So we can do dot filter. We can and have it be, I forget if they, okay, yeah, they're just using keyword arguments. This we were doing assault types before, so just pull the notebook back up. So one of the things that we were matching here, we were doing offense category equals assault and offense location equals school. So if I copy this into here, can everyone see the stuff on the bottom of the screen there? I know it's just at the bottom. Okay, I'll make it a little bigger too. Okay, so filter. So they're doing keyword arguments, which means we don't use this double. There. Okay, so we're going to filter our query where the offense category equals assault and the offense location type is a school, and we're going to grab the first object. Offense category. What am I missing? Oh, filter by. Okay, so here's the first crime, and really if I want to use that, instead of just calling this, I should assign it to a variable so we can use it. Let's just say our C equals that. So now we can use C, and we can see that our offense type is in fact an assault. It contains assault. And if we wanted to access the coordinate, we can do latitude and longitude. So it's, if we were mapping it, so there's the coordinate where it happened. And notice, now that we're in Python, we're treating this as though we're a native Python object, because it is. We are able to query a database using native Python, and then treat each row in there as a native Python object. And if we get rid of this first, in fact, you can also do limits. Any kind of SQL query parameters, limit, width, filter by, those are all going to have functions in here that you can use. So anything, in theory, anything that you can write in a raw SQL statement is going to, you're going to be able to use that as though it were a native Python function. But I should have C, yeah, so it's a query object. So I can do for a crime in C, print, let's do our latitude, longitude. Let's do crime. So for every single one where there was an assault, here's all of the coordinates. And maybe we use this to populate a, if it already existed in a database, we could then read this data down into our Python session and create a visualization from it. So if we didn't have access to that, the CSV file directly, or if we weren't loading it into pandas, we'd be able to access the same information this way. Any questions? Mm-hmm. Yeah, so this filter, or we can do limit the first 5 instances of it. So now for crime and C, there should only be 5 of them. Okay. So that's it for today. All of the stuff, everything that we've been working on today is going to be up in the GitHub repo. I'm going to add plenty of comments to it, as well as links out to the documentation. And I'm also going to push out this SQLite database file into the repository because we're going to use it as our database backend for our Flask web server next week. Okay, question?
What's the name of the repo?
Oh yeah, so I'll put the repo back up here. I'm also going to post it back in the meetup page as well. So thank you all for coming. And if Lee has anything else to say before you guys leave.
Can you go over real quick how you were doing that query? Because I do like sesh.query capital crime, and it says that that's not an object.
Oh,
Maybe I missed that.
so when we do this, now that sesh object is something that we just returned from this get session in there, just as a helper function. We did an explicit import of from models import get session comma crime, uppercase crime. So if you just do import models, you would need to do models session equals models dot get session, or in this case session dot query models dot crime. Yep.
Do you mind pushing it so that I can zero I can make it?
Yep. Okay. Let's save. All right.
Actually, just try MySQL.
Okay. Commits and push. All right, so it's back up here. Here's a repository. We can go into data, and here is our SQLite database, as well as our models.py file. So like I said, I will go back in and add plenty of comments to this, to these saying exactly what's going on. So see you all next week.
Thank you.